In this video, I'm going to talk about some of the specifics for a program that uses inheritance with the pet class, which is an abstract class, and a cat subclass, dog subclass, and a loud dog subclass. So first I want to take a look at the pet class. So there's a couple new things here in this class, one of which is the word abstract that we see here in the class header, and also a word abstract here in front of the speak method. When we use inheritance, the basic idea of inheritance is to factor out the common elements into a class that's very high on the hierarchies. So as you can see here in the diagram, pet's on the top of the hierarchy. The reason why it's abstract and what the name abstract implies is that it's virtual. It's not really there. We're never ever going to create a pet class. It's merely there to use as a placeholder for common information. This abstract in front of the method name, public abstract string speak, means that it's a method that we haven't written. And you'll see here there's a semicolon at the end, which we don't have in front of any other methods, or at the end of any other methods. And it means that each subclass will indeed have a speak method, and that you will have to write the code for that speak method. So this is merely saying that you're going to have one in every subclass of pet. Another thing here that's interesting is I have this data member called string name, private string name, and I have a constructor here that takes a string name as well. So if you look at the line of code here, name equals name, that's a little unclear or confusing at best. What I can do to make things a little more clear is I can use the word this, the keyword this, and say this.name. What this means is it refers to the name variable of the pet class, this pet's name. So you don't have to worry about name confusion when you're creating methods as you write programs. So if I write this.name, basically what it's saying is I'm taking the string parameter name and I'm going to set this pet's name equal to that. So you don't have the name equals name confusion. Other than that, we have a get name getter that returns a string and so forth. So that's the pet class. One of these subclasses we need to write is cat, and the keyword that creates a connection is the word extends, as you can see here. Public class cat extends pet, and what I'll do here is I'll just comment it out for a second and compile it, and you can see if I take that out, the line that was there is gone. If I go back in and put extends pet, that word extends pet puts the line back, and I have an error because I'm not done with the constructor yet. So you'll see that word extends throughout. Dog extends pet, and allow dog extends dog. So in the pet class, I have a constructor that's written right here, and basically it's setting the name, and it could be much more complex and set many different things, but right now it just sets the name. So in each of the subclasses I have a constructor as well. So you would go in here and you would think that it's using the same idea, name, this name equals name would work. If I try to compile that, I get a problem. It says can't find symbol constructor pet. What's happening is this, because I've already written a constructor in the pet class, I almost have to reuse that, and I can use the constructor of a class right above me, one level above me, by using the super keyword. So if we do super name, this word super means use the class above me that supersedes me and pass the parameter name, which in effect will basically call the constructor from the pet class. It'll basically run this method. It'll call the method above it. So if I try to compile that, it looks like it works, and that's what's going to be common in the other ones. I'm going to say super name, which will basically call the constructor right above me. And then loud dog's interesting because if I do super name, actually there's a chain of events that happens. When I say super name, because we cannot use super.super, we can't call super twice in a row. Super calls the constructor of the class right above me, which is a dog, but then dog, because it uses super, calls the constructor right above it, which is a pet. So when you construct a loud dog, as we will in a minute, you're actually causing a chain of events to occur that track all the way back to a pet. And for the speak method, I have something very simple here. It's just a woof. And a loud dog is supposed to repeat that woof twice. So here's a second use of super. The first use is to call a constructor in a class above it, but I can also call any method. I can say return super.speak. Call the speak method of the class right above me. And since the goal of this was to repeat it twice, I'll just write it twice. And I'll return whatever a dog says twice. Compile that, and we should be fine. And to test all this, I'll create a couple animals. I have a dog, create a cat, new cat, and a new loud dog. Doug2 equals new loud dog. Doug2. And what I can do is I'll ask each of them to speak. So I'm going to say system.out.println Doug.speak. And then I'll basically copy that a couple times and ask each person. So that's, I'll ask Doug to speak, I'll ask Lester to speak, and I'll ask Doug2 to speak. So Doug is basically a dog. He'll speak and say woof. Lester's a cat. He's going to say meow. And Doug2 is a loud dog, as we define it here. So it's going to say whatever Doug says twice. So if I compile that and run everything, you can see that what happens there. Now the really cool thing about inheritance is this. Whatever dog says, loud dog says twice. So if I change dog to say something else, he'll speak English, you know, hello. I don't have to change loud dog at all. It will basically repeat what dog does. So if I recompile and run, you can see here, here's our dog, our cat, and our loud dog says whatever he wants twice. So it's basically automatically updated. And that would be the second use of super. So we have two uses of super. One to call a constructor from a class above it, and super dot is to call any method of the class above it. And as I mentioned before, we can't not say super dot super because there's a chain of events that occur, and if you ever had to call super dot super, in other words, override an intervening class, then the design of the hierarchy probably was not right because everything should follow logically. Everything should be a more specific version of the other class above it. And one last thing. This is polymorphism. Each of these things is a pet. A dog is a pet, a cat is a pet, a loud dog's a pet. I can create collections of pets and put many different things, many seemingly different things into the same collection, an array list. So I'll create an array list of pets, call it kennel, equals new array list of pets. Now, we're using the abstract class pet as the type. So this array list can only hold pets, but what are pets? Dogs, cats, and loud dogs. I can hold them all. So I'm going to add each one of these to the array list and see if we are okay. I'll add Doug. I'll add Lester. And I'll add Doug2. So even though these things are seemingly different, they're all really just pets. And then just to make sure it all works, I'm going to create a loop that makes them all speak with one for loop. For each pet P in the kennel, I'm going to, with one line of code that's independent of the type of thing at each element, system.out.println, and I'll say p.speak. So the first time through, it'll pull out the dog. Is a dog a pet? Absolutely. So it'll run the dog speak method. The second time through, it'll see a cat. Is a cat a pet? Absolutely. I'll tell the cat to speak. The third time through, I'll see a loud dog. Is a loud dog a pet? Absolutely. It'll ask it to speak. So this little for loop is very powerful because if I have hundreds of things, I can process hundreds of elements, thousands of elements with one for loop. And nowhere in the for loop do I ever refer to anything specific. And in the future, if I create more objects, that are pets, which I may not even know of at runtime or when I write the code, this for loop does not need to be changed at all. So anything new will not break the code. So if I compile this and run, I can see here's my first set of printouts and my second set of printouts. So the polymorphism here is very powerful. And if you think about how this is used in real life, if you have a website like Amazon, and when they have sets of books or sets of CDs or sets of whatever they're selling, they can have a simple loop to process the elements, and they can add, delete, and change things at any point in time. But because they're polymorphically processed, you don't ever have to change the processing loop, which allows them to update, change products instantaneously. That's a wrap.